Hi guys! Welcome sa enginerdmath channel. Sa video na to, ituturo ko sa inyo ang finding determinants using cofactor expansion method. So kung gusto nyo itong matutunan, just keep on watching. Okay, so this time ay tuturo ko naman sa inyo ang finding determinants using cofactor expansion method. So, meron na akong previous video about finding determinants kung saan nag-consider tayo ng determinants ng 3x3 matrix kung saan ginamit natin is yung basket method. So, ngayon is mas i-generalize natin yung paghanap ng determinants using cofactor expansion method. So, pwede natin itong gamitin kahit anong size ng square matrix natin. 3x3, 4x4, 5x5, and so on. Okay? So, meron na rin akong previous videos about introduction to matrices, mga types nito, as well as yung iba't ibang operations. So, kung hindi nyo pa yung napapanood, isililink ko na lang para ma-check nyo. Okay? Pero bago tayo dumako sa pinaka-topic natin na finding determinants using cofactor expansion method is mag-define muna tayo ng terms which is the minor and cofactor of an element. Kasi magagamit natin ito sa cofactor expansion method. So, sabi, minor of an element if A is a square matrix of order n where n is greater than or equal to 2, the minor of an element A is the determinant m sub jk where m sub jk is the submatrix obtained from A by deleting the row and column containing the element. And for the cofactor of an element naman, if A is the square matrix of order n, where n is greater than or equal to 2, the cofactor of an element is plus minus minor, is the plus minus minor of the element, that is, A sub jk is equal to negative 1 quantity raised to j plus k m sub jk. Okay, so para ma-illustrate natin yung definition ng minor at cofactor of an element at kung paano ito hanapin, ay illustrate natin sa example. So suppose meron tayo matrix B, 2x2 matrix, 2 row and 2 column, tapos meron tayong elements inside na A sub 1, 1, A sub 1, 2, A sub 2, 1, at A sub 2, 2. So, hanapin natin yung minor of an element. So, pwede tayong pumili kahit anong element yung hanapan natin ng minor. Let's say itong element A sub 1, 1. So, dun sa definition ng minor, hahanapin natin yung element na natira kapag kinross out natin yung row at column kung saan nandoon yung ating kinoconsider na element A sub 1, 1. So, yung A sub 1, 1 is under column 1, right? So, kapag minark natin yung column ni A sub 1, 1, tapos yung A sub 1, 1 din is under row 1. So, kapag minark natin or nilinyahan natin yung row ni A sub 1, 1, which is row 1, mapapansin nyo, meron tayong natirang element. Ano yon? Yung hindi kasama doon sa minark natin. Etong A22. So, therefore, yung natirang A22, yung minor niya is kukuhain natin yung determinant. Okay? Kaso dahil isang element lang naman siya, automatic, yung value ng determinant natin na to ng A22 is pareho lang. A22 pa rin. So therefore, A22 yung minor nung element A11. And then, para naman sa cofactor of an element, so let's say consider na natin yung cofactor nitong element A11. So, kung anong nakuha nating minor niya, which is A22, right? Mumultiply lang natin yon sa negative 1 raised to j plus k. Kung saan yung j tsaka k is, yung kinoconsider natin is A11, right? Yung j is yung row nung element natin, tapos yung k is yung column ng element natin. So, therefore, j is 1 and k is 1. So, therefore, we have negative 1 raised to 1 plus 1 times A22 or negative 1 raised to 2, A sub 2, 2. Negative 1 raised to 2 is simply positive 1 times A22 or simply A22. So, yung cofactor ng element A11 is A22. So, kung mapapansin nyo, yung cofactor, pwede siyang maging value niya is plus minus nung ating minor nung same element. Kasi nga, di ba, meron tayong negative 1 na nakamultiply raised to j plus k. So, kapag even yung sum ng j plus k natin, i-multiply lang natin sa positive 1 yung nakuha nating minor nung kino-consider na element. At kung add naman yung sum ng j plus k natin, i-multiply lang natin sa negative 1 yung minor ng kino-consider nating element para makuha natin yung cofactor nung same element. Okay? Next, dumako na tayo sa pinaka-cofactor expansion method to find the determinants of a matrix. So, sabi, using the cofactor expansion method, the value of the determinant is the algebraic sum obtained by multiplying each element of the row or column by the cofactor or signed minor. So, tulad ng sinabi ko, gagamitin natin yung concept nung cofactor dito sa cofactor expansion method from the word itself sa paghanap ng determinant. So, pipili lang daw tayo ng isang row or column, tapos i-multiply natin each element ng row ng column na yon sa cofactor nung same element. So, for example, kung i-consider natin itong determinant ng 3x3 matrix, pipili tayo ng isang row or column na i-consider natin. So, kahit ano, let's say itong row 1 na lang, yung may element na A11, A12, tsaka A13. So, i-multiply natin yon yung bawat element ng row na yon, yung A11, A12, tsaka A13, doon sa cofactor nung element. So, sa A11, ano yung cofactor niya? Eliminate natin yung row 1 at column 1. Ang natira is A22, A23, A32, A33. Determinant, right? And then, multiply pa natin sa negative 1 raised to, dahil row 1, column 1, 1 plus 1. Or 1 squared. Okay? Plus, add naman natin yung pangalawang element, yung A12, times dun pa rin sa cofactor niya. Pag hinanap naman natin yung cofactor ng element 1, 2, 2, cross natin yung column niya, tsaka yung row niya, ang natira is A21, A23, A31, A33. So, A21, A23, A31, A33. Determinant. Then, multiply pa natin sa negative 1 raised to, dahil meron tayong element A12, yung row niya is 1, plus yung column niya is 2. So, 1 plus 2 is 3. Or negative 1 raised to 3. Then, plus, last, ito naman sa A13, multiply natin sa cofactor niya. So, determinant ng pag kinross natin yung column at element kung saan kabilang si A13, ang natira is A21, A22, A31, A32. So, determinant ng A21, A22, A31, A32. Times negative 1 raised to, dahil element 1, 3, 2 tayo, 1 plus 3. Or 4. So, simplify lang natin. Itong negative 1 square is positive 1. So, parang A11 na lang. Times, apply natin yung paghanap ng determinants ng 2x2 matrix. So, product nitong diagonal, A22 times A33, minus product nitong diagonal, pataas na A23 times A32. So, times A22 times A33 minus A23 times A32. Okay, then, negative 1 raised to the third is negative. So, parang minus A12 times determinant nito, product minus product. So, A21 times A33 minus A23 times A31. Then, negative 1 to the fourth is positive 1. So, plus tayo, A13 times determinant sa dito na lang. Determinant nito is product nito minus product nito. So, A21 times A32 minus A22 times A31. So, therefore, ito yung value ng determinant natin doon sa matrix A. Okay? So, again, pwede kayong pumili ng anong gusto nyong i-consider na element or column. Pero ang isasuggest ko is kung meron kayong makitang element or column na maraming zero para ma-eliminate nyo agad yung paghanap nyo ng determinant nung considered element na yan. Kasi 0 siya, diba? 0 times, pag ginanap nyo yung determinant, yung cofactor is 0 pa rin. Para mas mapadali or mas mabilis yung pag-solve nyo ng determinant. Okay? So, pwede nyo nga rin i-extend to up to 4x4, 5x4. Yun nga lang, kapag meron kayong 4x4, imumultiply nyo muna sa 3x3 matrix yung bawat element. 4 yon. And kung i-continue pa yung process, yung 3x3 matrix na yon, hahanapan nyo uli ng determinant by cofactor. So, marireduce siya sa 2x2. So, kapag 2x2, pwede nyo nang ma-apply yung paghanap ng determinant ng 2x2 matrix. So, medyo mahaba nga yung process nitong Cofactor Expansion Method, especially kapag malaki yung ating square matrix. Okay? So, para ma-illustrate natin yung concepts at formula for the minor cofactor as well as yung Cofactor Expansion Method sa paghanap ng determinants, ay mag-solve tayo ng examples. For the first one, we have find the minor and cofactor of element A23 of 4x4 matrix C. Okay, so meron tayong 4x4 matrix C. Hanapin daw natin yung minor at cofactor ng element A23. So, ang row natin is 2, yung column natin is 3. So, row 2, column 3. So, ito. Okay, so anong mga natirang element na hindi na-cross? So, itong 1, 2, 4, 9, 10, 12, 13, 14, 16. So, 1, 2, 4, 9, 10, 12, 13, 14, 16. So, yung minor, determinant niyan. Okay? So, pwede natin i-apply dito yung Cofactor Expansion Method. So, consider natin itong row 1. So, dito muna tayo sa element 1. So, 1 times yung cofactor nung element 1. So, yung cofactor niya is column 1 tsaka row 1. Cross natin. Nang natira is itong 10, 12, 14, 16. Determinant nila. Times negative 1 raised to 1 plus 1 or 2. Plus dito naman sa element 2, times yung cofactor niya. So, cross natin yung column 2 tsaka row 1. Ang natirang element is 9, 12, 13, 16. 9, 12, 13, 16. And then, multiply sa negative 1 raised to. Dahil ang element natin is 8, 1, 2. So, 1 plus 2 or 3. Then, plus ito naman sa element 4. Multiply sa cofactor niya, cross natin yung column 3 tsaka row 1. Nang natira is 9, 10, 13, 14. 9, 10, 13, 14. Then, negative 1 times, dahil yung 4 is row 1, column 3, 1 plus 3 or 4. So, evaluate na lang natin tong mga determinants. Dahil 2 by 2 na, apply na natin yung method. So, itong negative 1 squared is 1 times 1 is 1 pa rin. So, 10 times 16 is 160 minus 12 times 14 is 168 plus negative 1 cube is negative times 2. So, parang minus 2. Times determinant nito is product ng 9 times 16 is 144 minus product ng 13 times 12 is 156. Then, plus, negative 1 to the 4th is positive 1. So, times 4 is 4 pa rin. Times, determinant nito, product ng 9 times 14 is 126. Minus 13 times 10 is 130. So, simplify. 1 times 160 minus 168 is negative 8. Minus 2. 144 minus 156 is negative 12. Plus 4 times 126 minus 130 is negative 4. So, 1 times negative 8 is negative 8. Then, negative 2 times negative 12 is positive 24. Positive 4 times negative 4 is negative 16. So, negative 8 plus 24 minus 16 is 0. So, therefore, yung minor ng element A23 na 7 is 0. Okay, and then yung cofactor niya, so kung ano man yung nakuha nating minor na 0, multiply natin sa negative 1 raised to, dahil 2, 3 tayo, 2 plus 3. Or, negative 1 raised to the 5. So, negative 1 to the 5th is negative 1 times 0. So, dahil 0 lang naman yung minor niya, 0 din yung cofactor niya. Okay? Next, we have evaluate the given determinant below using cofactor expansion method. Okay, so meron tayong 4x4 matrix. So, using cofactor method, pili tayo ng gusto nating i-consider na row o column. So, ito na lang column 1. Kasi kung mapapansin nyo, yung mga elements niya is dalawa is 0. So, malilas na agad tayo sa paghanap ng determinant ng 3x3 matrix kasi itong dalawang element na to, pag multiply natin sa 3x3 matrix is automatic. Makakancel natin yung determinant ng 3x3 matrix na yon. So, last tayo ng trabaho. Ito na lang 1 tsaka 5 yung hahanapan natin ng 3x3 matrix. Okay? So, try natin. So, meron tayong unang element na 1 times yung cofactor niya. So, cross out natin tong row 1 tsaka column 1. Matitira is negative 5, 6, 2, negative 8, negative 2, 1, 1, 2, 0. Then, negative 1 raised to 1 plus 1 or 2. Okay? Plus, this time, itong 0. So, sige, pakita ko pa rin kung ano yung magiging cofactor. Cross natin yung column 2 tsaka row 1. Ang matitira is 3, 6, 2, 6, negative 2, 1, negative 5, 2, 0. So, 3, 6, 2, 6, negative 2, 1, negative 5, 2, 0. Times negative 1 raised to, dahil row 1, column 2, 1 plus 2. Or 3. So, mapapansin nyo, dahil nga 0 yung ating constant dito na nakamultiply sa determinant, makakancel natin yung value kung ano mang whatever determinant nito. Right? So, kahit hindi na natin hanapin, kasi in the end, 0 pa rin naman siya. Right? So, magiging less nga yung work natin. Okay? Plus 5. Dito naman sa element 1, 3. So, times cofactor niya, cross natin yung column 3 tsaka row 1. Determinant ng 3, negative 5, 2, 6, negative 8, 1, negative 5, 1, 0. Okay? And then, negative 1 raised to, dahil siya ay element A1, 3, so 1 plus 3, or to the 4th power. Then, last, plus 0. So, itong element natin na 0, multiply sa determinant niya. So, kahit hindi ko na nga ilagay, pero pakita ko pa rin kung anong magiging cofactor niya. Cross natin yung column 4 tsaka row 1, ang matitira is determinant ng 3, negative 5, 6, 6, negative 8, negative 2, negative 5, 1, 2. Then, negative 1 raised to, dahil element ano siya, 1, 4. So, 1 plus 4 or 1 to the negative 5. So, again, dahil 0 nga yung constant natin dito, parang makakancel lang tong determinant. So, in case nga na hindi 0 tong mga value na to, let's say, meron siyang value other than 0, hanapin nyo yung determinant, tas multiply nyo pa doon. So, matrabaho nga, right? Pero dahil meron tayong dalawang 0, tapos yung dalawa is non-zero, itong 1 tsaka 5, ito na lang yung hanapan natin ng determinant. So, parang na to, negative 1 squared is positive 1 times 1 is positive 1. Evaluate natin tong 3 by 3. So, i-reduce naman natin siya ngayon sa 2 by 2 para ma-apply natin yung formula. So, pili ulit tayo ng pwedeng i-consider na element. So, ito na lang sa baba kasi meron tayong 0 para dalawa na lang yung ating hanapan. So, 1, dito muna tayo sa element 1. Cross natin yung kanyang row at column. Ang natira is what? Cofactor niya is determinant ng 6, 2, negative 2, 1 times negative 1 pa to, right? Raised to, dahil ano siya? Row 3, column 1. So, 3 plus 1 is 4. And then, plus, ito naman sa 2, times yung cofactor niya, cross natin tong column 2, tsaka row 3, ang natira is determinant ng negative 5 to negative 8, 1. Right? Then, times negative 1, so, dala na siya, row 3, column 2, 3 plus 2 or 5. Plus, last yung 0, cofactor niya is, ito kahit din yun na kuhain yung mismong determinant, pero papakita ko pa rin yung kanyang cofactor. Negative 5, 6, negative 8, negative 2, then negative 1 raised to, dahil ano siya? Row 3, column 3, 3 plus 3 or 6. Okay, so lahat ng to, multiply natin sa 1 na kasi meron tayong constant 1. Pero dahil 1 nga lang siya, parang kaya hindi na natin i-multiply kasi equal pa rin siya dito sa expression na to. So, simplify natin. So, negative 1 to the 4th is positive 1. Positive 1 times 1 is still 1 times determinant nito. So, 6 times 1 is 6 minus negative 2 times 2 is negative 4. Then, plus negative 1 to the 5th is negative 1 times 2 is negative 2. So, parang minus 2 na to. Times determinant na to, negative 5 times 1 is negative 5 minus negative 8 times 2 is negative 16. Then, plus, so 0 na to, right? Kahit di ko na i-consider. So, 1 times 6 minus negative 4 is 6 plus 4 or 10, right? Minus 2 times negative 5 minus negative 16 is 11. So, 1 times 10 is 10 minus 2 times 11 is negative 22. Or 10 minus 22 is negative 12. So, ito yung isang value. So, dito naman yung pangalawa. So, itong dalawa nga is 0 na. So, tingnan natin evaluate. Ito na lang. Yung negative 1 to the 4 times 5 and then itong determinant. So, negative 1 to the 4th is positive 1 times 5 is 5. So, dito ko na lang isusulat. So, 5 times. So, consider uli natin ito na lang row 3 kasi may 0 ulit. So, meron tayong element na negative 5. So, dito muna tayo sa negative 5. So, 5 times negative 5 times cofactor niya. Cross natin yung row 3, column 3. Negative 5 to negative 8, 1. Negative 5 to negative 8, 1. Then, times negative 1 raised to, ano siya? Row 3, column 1. So, 3 plus 1 is 4. Plus, ito namang element 1. So, 1 times cofactor niya. Cross natin tong column 2, tsaka row 3. Natira is 3, 2, 6, 1. 3, 2, 6, 1. Then, times negative 1 raised to, dahil siya ay row 3, column 2, 3 plus 2 or 5. Plus, so 0, times, cofactor niya, cross natin itong column 3, row 3, natira is 3, 5, 6, negative 8. 3, 5, 6, negative 8. Then, negative 1 raised to, dahil column 3, dahil row 3, column 3, 3 plus 3 or 6. So, meron tayong 5 times. So, simplify ko na agad Negative 1 to the 4th is positive 1 times negative 5 is negative 5 times determinant is negative 5 times 1, negative 5 minus negative 8 times 2 is negative 16. So, negative 5 minus negative 16 is positive 11 times negative 5 is negative 55. And then itong negative 5 raised to the 5th is negative 1 times 1 is still negative 1 times determinant nito. So 3 times 1 is 3 minus 6 times 2 is 12. So 3 minus 12 is negative 9 times negative 1 is positive 9. Next, dahil ito ay 0, kahit hindi na natin kuhain yung value. So, meron tayong 5 times, ito, yung negative 55 plus 9. So, negative 55 plus 9 is negative 46. Then, times 5 pa is negative 230. So, yung dalawang nakuha natin is itong negative 12, tapos itong ngayong negative 230. So, add natin. Negative 12 plus negative 230 is negative 242. So, therefore, ito yung value ng ating determinant. negative 242. Okay? Okay, so I think that's it for this video, finding determinants using cofactor expansion method. So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.